so everybody, a particle of motion, according to the laws of motion, S equals F of t. So everybody, down here's your function, right, which I rewrote up here. S of t, it says F of t, but guys, this is a position function. T cubed minus 12t squared plus 36t. Every time you do derivatives, you're going to use this function. First thing I do is I factor it. All right, because I just want to know. I'm going to make some graphs at the ends that you don't need, okay? Everybody, derivative of this, power rule, easy, right? 3t squared, negative 24t, 36. That is velocity. Derivative of position is velocity. Everybody, the next thing I do is I factor that. All right. You notice I did those two steps because I knew this would have velocity. Letter A was find velocity at time t. Everybody, this is the answer to letter A, right? There's A. That's velocity at time t. Then it says, what is the velocity after 3 seconds? What do I have to do? Just put 3 in. And it's asking what v of 3 seconds is. So I put 3 in this equation, right, and get a value. 27 minus, 72, which is negative 45 plus 30. Is it negative 9?
Yeah.
Oh, good. Guys, what are the units? Meters per second, right? Everybody, let's be clear about how the AP would grade this. Negative 9 would be a point. Meters per second would be a point. So we will, listen, so you don't have units on the test, I just mark it wrong. Because I want you to get both. You got to have units every time. All right. Oh, it's feet. Oh, whoops. All right, feet per second. I probably let you get, oh yeah, it's feet. S and feet. You guys, you threw me off. Good job. All right. When is the particle at rest? Everybody. This is good practice. The AP loves it. In fact, sometimes it doesn't even give credit for the answers. It'll give credit for you saying V of t equals 0. That's when the particle's at rest. Do you guys agree? So we state the obvious, all right, and then we find answers. So, and again, we're just starting to talk about what the AP grades, right? So now, what values of t make it 0? 2 and 6 seconds. So there's the answer to part C. It's at rest at time 2 and time 6. Then it says, when is the particle moving in a positive direction? All right, I'm going to make a sign table. This is, again, we did this in pre-calc. I'm going to make a sign table for letter D. I have my velocity function. I know at time 2, the velocity is 0. I know at time 6, the velocity is 0. Everybody, polynomial. Intermediate value theorem, it's continuous, right? So IVT states that it's not going to go positive or negative without going through a 0. I just got to figure out what the regions are. So I pick my favorite numbers. My favorite number left is 2. How about 0? Guys, I plugged 0 into V up here. What do I get? Positive 36. So it's positive. Everybody, why wouldn't I put in negative 7? Huh?
It's a big number.
Time can't be negative. We are not supermen and women. We don't have time be negative. What's the domain of this function? 0 going forward. It is time, time, time. No negative time, damn it. All right? So, that said, my favorite number between 2 and 6, I'm going to pick 4. Everyone, I just care about sign. So I go to my factored thing. I plug in 3 is positive. 4 minus 2, positive. 4 minus 6, negative. Boom. Actually, we should be able to tell that this alternates sign, right? Because there's no powers on our factors. But then we prove it by putting a big number in 247 seconds. Positive, positive. All right, everybody, that's my sign table. Then it says when is the particle moving in a positive direction? When the velocity is positive. So it's positive from, I suppose I can leave it red. How about 0 to 2 and 6 to infinity? That's positive. All right, everybody, now it wants the total distance traveled for the first 8 seconds. All right, I'm going to draw a diagram. I'm going to do F first. This is why I like to read them all. I'm going to make the diagram first because that's going to help me find the distance. So my diagram, do it in black. My diagram, everybody, if I plug in 0 up here for position, you guys see, you plug in 0. It starts at 0, 0. It starts at the origin, right? Does everybody see that? So I'm going to do my time 0, S0. Everybody, your velocity zeros tell you where to go to, right? So this particle goes forward till time 2. So over here, I'm going to go time 2. And I'd really like to know, and I should make this a little smaller. I'd really like to know the position at time 2. So I got to go all the way back up here and put 2 in, right? Because I want to know my position. -4 times -4 is 16 times 2, 32? 32 feet. 32 feet. All right, so the particle goes forward for 2 seconds. Then what happens? It goes backwards for 6. Now, I'm going to try to actually draw this correctly for once. I don't know if time 6 is in between 0 and 32, or if time 6 is over here. I don't know where the position is yet until I plug 6 back in. But everybody, that's why I like factoring. If I plug in time 6, what do I get? 0. So this goes back at time 4. The position is 0 again. And then everyone, I know it goes this way because I know it changes direction again. And then I got to be at time 8. If I plug 8 in here, 8 minus 6, 2. 8 minus 6, 2. 2 times 2 is 4 times 8, 32. Oh, haha. Time 8, S is 32 again. You definitely know this is a book problem now. Does everybody agree? It's so pretty. All right. Everybody, what's my position at time 8? What's my position? 32 feet. Right, 32 feet. You whispered it just so you won't be on YouTube. Good job. 32 feet. Everybody, have I traveled 32 feet in the first 8 seconds? No, this particle has moved around a whole lot, right? This particle went 32 feet, 32 feet, 32 feet. So what's the distance for letter E? 32 times 3, 96 feet is the distance it traveled in 8 seconds. What's its position? It's at 32 feet. Big difference, right? Big difference. All right, last thing. We're not gonna do H today. Shoot. Or I. We'll have to save those and do those next week. Everybody, in fact, it makes sense to pick up from here. But guys, how would you find the acceleration? What would be the next step to start this? Derivative of velocity. And again, don't use the pretty one for the derivative. Don't use the factored one. The factored one is pretty for zeros. For taking derivatives, the pretty one is this one. We'll pick up with this on Monday.
Can you re-go over how you got those numbers for the diagram?
Yeah, so I started at time 0. S0 is coming from this equation. Then I picked the 2 and the 6 based on the velocity change. Right now we're leading you to water because we're having you do this step first. If I just ask you for total distance, you still have to do this step. Because you have to, when you look at the position function, you have no idea when it's going backwards unless you have the velocity. So then I used 0, 2, 6, and the 8 was from the word problem. And all the positions come from the position function.
Why is that so?
Time 4, position 0.
Why does it?